source of loss in a wireless system. What we follow is what's known as the 6 dB rule. Close inspection of the path loss equation yields a relationship that's very useful in dealing with link budget issues. Each 6 dB increase in EIRP equates to doubling of range. Conversely, a 6 dB reduction in EIRP translates into cutting of the range in half. And you can see from this table that as your distance increases, we do see a significant loss in decibels. And just as important as having good performance on our wireless LAN system, proper antenna installation is going to provide us the best possible coverage in a wireless LAN and also prevent damage or destruction of equipment or even personal injury. So what we want to focus on is when we decide the antenna polarization and we identify how many antennas we're going to need, we need to follow the appropriate mounting orientation and alignment procedures. The first thing that we'll do is to focus our efforts on placement of antennas, also on mounting, how the antenna itself is going to be mounted for safety reasons and for appropriate use, the orientation of the antennas, and the alignment of the antennas themselves. You also need to make sure that you do focus on safety because antennas, especially high-gain antennas, can actually cause severe injury or death. And we want to make sure that we always follow the safety regulations that are associated with the antenna that we're going to use. So we'll begin with placement and mounting. With placement, we want to start off by mounting omnidirectional antennas attached to the access points near the middle of the desired coverage area whenever possible. Place the antenna as high as possible to increase the coverage area, being careful that users located somewhat below the antenna still have reception, particularly when using high-gain omni antennas. Outdoor antennas should be mounted above obstructions such as trees and buildings so that no objects will encroach on the Fresnel zone. Also, with mounting, once you have calculated the necessary output power, the gain, and the distance that you need to transmit your radio frequency signal, and you've chosen the appropriate antenna for the job, you've got to mount it. There are several mounting options that you'll have. Whether it's a ceiling mount or a wall mount or pillar or ground, you need to make sure that you do follow the appropriate procedures. There is no perfect answer for where to mount your particular antenna because everybody's environment is going to be a little bit different. The recommended placement and the mounting of the antenna will always be part of a proper site survey. One of the biggest things that you have to focus on with antennas in a wireless network is orientation and alignment. Antenna orientation actually determines the polarization of the antenna. If an antenna is oriented with the electric field parallel to the Earth's surface, then the clients, if the antenna is mounted to an access point, should also have this same orientation for maximum reception. The reverse is also true with having both the electric field oriented perpendicular to the Earth's surface. You want to make sure that your clients have that type of antenna orientation as well. The throughput of a bridge link will be drastically reduced if each end of the link does not have the same orientation of their antennas. So you need to make sure that the orientation of antennas are like at both ends. Another major factor is alignment. Now, antenna alignment is sometimes critical and sometimes it's not. Some antennas do have a very wide horizontal and vertical beam width, allowing configuration and aiming of antennas to where when we're doing building-to-building bridging, we actually only have to aim them in the general direction of the other building, and we get almost perfect reception. But alignment is always more important when we're dealing with long-distance bridge links using highly directional antennas. Wireless bridges come with alignment software in most cases that will aid the administrator in optimizing antenna alignment for best reception, which does reduce lost packets and high retry counts while maximizing signal strength. Something that might be very familiar to you is actually aiming a DSS satellite, where you're actually trying to get the best TV reception. There's always software which will give you signal strength as you proceed through this process to make sure that you've got the best signal possible. Anytime you're using access points with omnidirectional or semi-directional antennas, proper alignment is simply a matter of covering the appropriate area so that the wireless clients can connect in places where connectivity is required. The other major factor that you have with antennas is safety. Radio frequency antennas, like other electrical devices, can be very dangerous to implement and operate. You want to make sure that you follow certain guidelines whenever you or anyone that you work with is installing or otherwise working with radio frequency antennas. First and foremost, follow the manual. Carefully follow any instructions that are provided with all antennas. Following all instructions will prevent damage not only to the equipment, but also avoid personal injury. Most of the safety precautions found in antenna manufacturers' manuals are simply common sense. The other thing is, do not touch an antenna when power is applied. Never touch high-gain antennas to any part of your body or point it towards your body while it's transmitting. The FCC does allow very high amounts of radio frequency power to be transmitted in the license-free bands when configuring point-to-point links. Putting any part of your body in front of a 2.4 gigahertz highly directional antenna that is transmitting at a high power is equivalent to putting your body inside of a microwave oven. You want to make sure that you do not touch or get in the way of a highly directional antenna in this case. The other thing you may consider, especially for high gain, is professional installers. For most of your elevated antenna installations, consider using someone who's used to being up in high places and installing these highly directional devices. Professional climbers and installers are trained in proper climbing safety will be able to better install and secure your wireless LAN antenna if it's got to be mounted on a pole, a tower, or some other type of elevated construction. You also want to be aware of metal obstructions. Keep antennas away from obstructions such as heating and air conditioning ducts, large ceiling trusses, building superstructures, and major power cabling runs. These type of metal obstructions do create a considerable amount of multipath. And since these types of metal obstructions do reflect a large portion of the radio frequency signal, if the signal is being broadcast at high power, the reflected signal could be incredibly dangerous to bystanders. Also be aware of power lines. Antenna towers should obviously be a safe distance away from overhead power lines, and normally the recommended safe distance is always twice the antenna height. Since wireless antennas, though, are generally small, this recommended practice does usually not apply. However, just be very careful around power sources such as this. And finally, anytime you're dealing with outdoor installations, always make sure that grounding rod guidelines are followed. The National Electric Code and local electric codes for proper outdoor antenna and tower grounding can be followed. Grounding rods usually should have less than 5 ohms to earth ground. The recommended resistance is 2 ohms or less. Grounding rods can prevent damage to the wireless LAN equipment and might even save the life of anyone climbing on the tower if the tower is struck by lightning. Not a guarantee, but at least it can help. So, now we understand. We mount our access point flat with both antennas pointing horizontal. What are the chances that we're going to have any vertical alignment whatsoever with any of our PC systems? We have to make sure the polarization is the same on our antennas. Now we understand what it means when antennas are off a little bit and how we can actually correct those problems. Now realize, even though we understand polarization now and understand the way that signals themselves in radio frequency are going to focus within antennas and beam widths, it is very important that you do not disregard the concept of a site survey. The site survey is going to be a very important factor in determining what the orientation and the placement is of the antennas in your radio frequency solution. Have you ever tried to plug in a device? You've looked all around for a wall socket and you can't find one. You ever tried to add new devices to your data center and you're without extra power to be able to do so? Well, think about this. With Cat5 Ethernet cable, we only use 4 of the wires out of 8. Why couldn't we actually transport power over some of those wires? That's known as power over Ethernet. It's becoming very, very popular in today's industry for a lot of things that can actually take power right over their Ethernet port, such as wireless access points or even IP phones, giving us the ability to pretty much install these devices anywhere on the network. But I've got to warn you, it's not a standard yet, so we do have to be very careful about how we use power over Ethernet and how we understand what different vendors might do in their own implementations. Power over Ethernet is a method of delivering DC voltage to an access point, a wireless bridge, or a wireless workgroup bridge over the Cat5 Ethernet cable for the purposes of powering the unit. Now, in our context, that's what it's limited to, but in the industry, we are seeing power over Ethernet being used to deliver power to a lot of other devices too, such as IP phones. One of the things about power over Ethernet is it's used specifically when we don't have an AC power receptacle available, where wireless LAN infrastructure devices need to be installed in the network environment. However, it can replace it even if there is a power receptacle. The Ethernet